Hey guys, welcome back. So last time we looked at how to generate our key, and with that, when I run it, hopefully, I should get a key. So I've got two different sets of keys here, but I'm going to go with the second one. So A is going to be equal to C, B is going to be equal to X, C is going to be equal to V, and so on and so on. So this is now my key. Now, I'm going to make a new file, and I'm going to use this to make my encryption software, my encryptor, I don't know what you call it. But okay, so let's start with the key. Is going to equal, well, whatever I took from that file. Now, I could automate that in a way that I could generate a new key or other such things, but for now, that's fine, doing it this way. I'm going to have the plain text. That's the text that I want to encrypt. I'm going to have the cipher. And that is the message that I'm then going to output later. Okay, so I want to take each letter of the plain text. Now, first of all, I guess I better ask the user. Oh my goodness. There we go, sorry. Two things at once is not my strong point. Okay, I'm going to ask the user to enter the text to encrypt. Okay, and that's the message that they want to encrypt. Now later, I'm going to change that to be reading in a text file, so we can deal with that later on, but for now, it's just going to be a sentence that they type. Now, for each, I want to look through each letter inside of what they've typed. So let's say, for example, they've typed A, B, C. I want to take A, and then B, and then C. And I want to find the equivalent on my key list up here. So, now in normal Python, you could do 4-letter in plain text. That's perfectly normal in regular programming. However, as we're focusing on GCSEs here, we can't do it that way for what we want to do with pseudocode and exam stuff. So we've got to say for x in range, 0 to the length of the plain text. So x is going to start at 0, then 1, then 2, and that's going to be the equivalent. That's going to go up to the length of the plain text. So, now again, I'm going to do this the longhand way to begin with, and then I'll try and shorten it down later. So, let's start by saying I'm going to have the Unicode value. Now, for those of you who don't remember Unicode or ASCII, sorry, not going to help you with that today, but basically each letter has an equivalent numerical value in the system, and Unicode and ASCII have the same value for the letters of the alphabet, which makes things very nice. So, the Unicode of the first character is going to be the ORD of plain text at position X. Okay, now this is, again, if our plain text was, I'll just put it underneath as an example, plain text equals ABC. So the Unicode value of A is 97. So now our Unicode is going to equal 97. Okay, now I want to convert it so that I can look up the position in the array. So in order to get that, and let's call that value the index. Oops, let's call that value the index of the array. So I want a 97 to equal the first position. So A is going to equal C. So 97 is going to equal 0. So how do I get that value? Well, I subtract 97. Hopefully you mathematicians have got that. So the index is going to equal the Unicode minus 97. Now, the actual letter that I get from that is going to be called, let's call it letter. letter equals nada, nothing. So the letter is going to equal the key at position index. So in this case, the letter is going to equal C. Oops, is going to equal C. So an A becomes C. And then I want to add that to my cipher. So the cipher is going to become C. So I want to do cipher equals cipher plus the letter. Now that's going to repeat. So then for B is going to be 98, which is going to be index 1. Index 1 is an X. So then the cipher, now we're not removing the C, so the next bit's going to be CX in our cipher. Is there anything else I need? Well, I hope not. So let's see, what do I get out as my cipher from that. Oops. So fingers crossed. If I save it, oops, I thought I saved you already, no? No, okay. Some ink. That's a terrible name. Oh, I've got one already of that exact name. There we go. Okay, so enter the text encrypt ABC. Now ABC should become CXV. Yay! Now we want to check it at both ends, so let's run that again. ABC, but we also want to do XYZ. So XYZ should be go to end of array. Oh, I always hate this thing, goes back away. Should be RPI. So we should have CXV RPI. Yay! So my encryption key algorithm thingy works. And that's how we can use symmetric encryption to basically hide our messages. Now again, this is not how it's done today. That's far too simple to crack, but it's quite a fun thing to get started with. And maybe you can think of ways, how could you make it a bit more advanced in different ways? For those of you who are following along in class, your task then is to make the decryption. So I want you to take this and I want you to run it the other way around and output I want them to be able to enter the cipher, which is, I want them to be able to enter the cipher and decrypt it back to being the original text. Okay, hopefully you can reverse engineer that and we can go from there. Alrighty, next time I might look at that decryption bit, but then I might also look at how to do a Caesar cipher as well, which is kind of fun. Okay, ciao ciao.